Hello again, welcome to part 2 of Tuesday, March 15th's recording. So remember that today we are using properties of lines tangent to a circle to solve problems. And so we already talked about our first theorem, as you guys saw in the last recording, and that was the theorem that is called tangent to a circle theorem. So for this recording, we're going to take a look at the second theorem for today. And that theorem is called two tangents theorem. And the two tangents theorem says, if two tangent segments are drawn to one circle from the same external point, then those segments are congruent. So here we have circle A, right, a circle with center A, and to that circle we have two segments drawn tangent. So CB is tangent to circle A at point B, and CD is tangent to circle A at point D. When this situation occurs, they're both tangent from the same external point C, then these two tangent segments are going to be congruent. So we can say that the length of CD is equal to the length from C to B. So for the rest of the class, we're just going to practice solving these theorems. So here we are given two segments tangent to circle T. The first is this segment here, and I can even name this point. I could say this is A over here. So we have a segment tangent to circle T called UA, and another segment tangent to circle T called AW. And so because of our two tangents theorem, by the two tangents theorem, we know that segment UA is congruent to segments WA. And if two segments are congruent, we know that their lengths are just equal to each other. So UA has a length of 3x minus 2, and WA has a length of 10. So we need to solve this equation for x. So in order to solve for x, we have to first get our variable term by itself. So if we want to get 3x by itself, we see that right now 2 is being subtracted from 3x, so we have to do the opposite and add 2 to both sides. That gives us that 3x is equal to 12 because these cancel. And then our last step is to divide both sides by 3. So that gives us a value for x of x equaling 4. We can even double check and plug it back in and check that these segments both equal 10. So if I did 3 times 4, I get 12 minus 2, that still gives us 10. So our value for x is equal to 4. Let's try another one. So here we want to solve for x. Again, we have the same diagram, just different expressions. So again, by the two tangents theorem, we can say that 5x minus 3 must equal 22. So to solve for x, we have to get the 5x by itself first. So we do the opposite of subtracting 3. We add 3 to both sides. That gives us 5x is equal to 25. And our last step is to divide both sides by 5. So that tells us x is equal to 5. Again, we can plug that back in just to verify we solved it correctly. So 5 times 5 is 25, minus 3 is 22, and that's what our other tangent segment equaled. So we know that we solved correctly. Let's take a look at a second type of problem involving the two tangents theorem. So here we're given a triangle KGI and lengths of various segments around this triangle. Notice that this triangle is surrounding the circle. So we say that the circle is inscribed in the triangle. And so what's kind of neat about this is that we have a couple of different tangent segments to the circle. So one of them would be KL and KJ. They're both tangent from the same external point K. We also know that LG is tangent to the circle from the same point as GH. And then last of all, we see that IJ is tangent, and so is IH from the same external point I. So basically, those colored segments are going to be congruent using our two tangents theorem. So we know that because KL and KJ are tangent from the same external point K, these are congruent. We know that LG is congruent to GH, so I'll mark those with 2 tick marks. And then finally, JI and HI are congruent. So, knowing the information that we know, if LG is 9, then GH is 9. If HI is 4, then IH is 4. And they tell us the whole length from K to I is 11. So if I just want to find this yellow part right here, I just take 11 minus 4, and that gives me 7. So I can determine that KJ is 7, which makes KL 7 as well. Let's try another problem involving the two tangents theorem. So here we want to find the entire perimeter of ABC. So that's just adding up AB, BC, and AC, all 3 sides of the triangle. Well, we know that when tangent segments are drawn to a circle from the same external point, those segments are congruent. So BE is tangent to circle G, and so is BF, and they're both tangent from the same point B, the same external point. So that tells us that if EB is 4, then BF is also 4. The same thing applies with AE and AD. They're 2 segments drawn tangent to the circle from the same external point. So that means if AE is 6, and so is AD. And then finally, FC is tangent to circle G from the same external point C as CD is. So if FC is 7, then DC is also 7. So to find the perimeter, we just add up everything around the triangle, right? The perimeter, add up all 3 sides. So we see that AB, we can do AB plus BC plus AC, and that's going to equal our perimeter. Well, AB, that is just, 6 plus 4, that whole side. So we'll do 6 plus 4. BC is 4 plus 7. And then finally, AC is 6 plus 7. And that is equal to our perimeter. Well, 6 plus 4 is 10. 4 plus 7 is 11. And 6 plus 7 is 13. So we add up all 3 values. 10 plus 11 plus 13 gives us a total perimeter of 34 units. All right, let's do one more. We want to find the perimeter of triangle ABC again. They tell us AE is 3. They tell us CD is 6. And they tell us BF is 2. So we can apply the same theorem that we did in the last problem, the two tangents theorem. AC is tangent to circle G from point A, and so is AD, which means that AD is 3 as well. BF is tangent to circle G, and BE is tangent from the same external point B. So therefore, if BF is 2, then BE is 2. And finally, CD is 6, and CF is tangent from the same external point C. So that makes those segments congruent as well. So if DC is 6, then FC is 6. So if we want to find the perimeter, then we just add up all of the lengths going around the entire triangle. So we have 3 plus 2 plus 2 plus 6 plus 6 plus 3. And if I add up all of those lengths going all the way around the triangle, 3 plus 2 plus 2 plus 6 plus 6 plus 3, then my perimeter is going to equal 22 units. And the last part of today's recording is just a couple more vocabulary terms. But I think I'll actually save that for tomorrow's class. So tomorrow we're going to look at tangent lines to circles and circles that are tangent to each other. Thanks for watching, and don't forget to answer the exit questions on the Google form that I put in the announcement.